Induction heating is the process of heating an electrically conducting object by electromagnetic induction, through heat generated in the object by eddy currents. An induction heater consists of an electromagnet and an electronic oscillator that passes a high-frequency alternating current through the electromagnet. The rapidly alternating magnetic field penetrates the object, generating electric currents inside the conductor called eddy currents. The eddy currents flowing through the resistance of the material heated by Joule heating. In ferromagnetic materials like iron, heat may also be generated by magnetic hysteresis losses. The frequency of current used depends on the object size, material type, coupling and the penetration depth. An important feature of the induction heating process is that the heat is generated inside the object itself, instead of by an external heat source via heat conduction. Thus objects can be heated very rapidly. In addition, there need not be any external contact, which can be important where contamination is an issue. Induction heating is used in many industrial processes, such as heat treatment in metallurgy, Czochralski crystal growth and zone refining used in the semiconductor industry, and to melt refractory metals which require very high temperatures. It is also used in induction cooktops for heating containers of food. This is called induction cooking. Applications. Induction heating allows the targeted heating of an applicable item for applications including surface hardening, melting, brazing and soldering, and heating to fit. Iron and its alloys respond best to induction heating, due to the ferromagnetic nature. Eddy currents can, however, be generated in any conductor, and magnetic hysteresis can occur in any magnetic material. Induction heating has been used to heat liquid e-conductors and also gaseous conductors. Induction heating is often used to heat graphite crucibles and is used extensively in the semiconductor industry for the heating of silicon and other semiconductors. Utility frequency induction heating is used for many lower-cost industrial applications as inverters are not required. Induction furnace. An induction furnace uses induction to heat metal to its melting point. Once molten, the high-frequency magnetic field can also be used to stir the hot metal, which is useful in ensuring that alloying additions are fully mixed into the melt. Most induction furnaces consist of a tube of water-cooled copper rings surrounding a container of refractory material. Induction furnaces are used in most modern foundries as a cleaner method of melting metals than a reverberatory furnace or a cupola. Sizes range from a kilogram of capacity to 100 tons capacity. Induction furnaces often emit a high-pitched whine or hum when they're running, depending on their operating frequency. Metals melted include iron and steel, copper, aluminium, and precious metals. Because it is a clean and non-contact process, it can be used in a vacuum or inert atmosphere. Vacuum furnaces make use of induction heating for the production of specialty steels and other alloys that would oxidize if heated in the presence of air. Induction welding. A similar, smaller-scale process is used for induction welding. Plastics may also be welded by induction if they are either doped with ferromagnetic ceramics or by metallic particles. Seams of tubes can be welded this way. Currents induced in a tube run along the open seam and heat the edges, resulting in a temperature high enough for welding. At this point, the seam edges are forced together and the seam is welded. The RF current can also be conveyed to the tube by brushes, but the result is still the same. The current flows along the open seam, heating it. Induction cooking. In induction cooking, an induction coil in the cooktop heats the iron base of cookware by cyclic magnetic induction. Copper-bottomed pans, aluminium pans and other non-ferrous pans are generally unsuitable. The heat induced in the base is transferred to the food via conduction. Benefits of induction cookers include efficiency, safety and speed. Both permanently installed and portable induction cookers are available. Induction brazing is often used in higher production runs. It produces uniform results and is very repeatable. Induction sealing induction heating is used in cap sealing of containers in the food and pharmaceutical industries. A layer of aluminum foil is placed over the bottle or jar opening and heating by induction to fuse it to the container. This provides a tamper-resistant seal, since altering the contents requires breaking the foil. Heating to fit. Induction heating is often used to heat an item, causing it to expand prior to fitting or assembly. Bearings are routinely heated in this way using utility frequency and a laminated steel transformer type core passing through the center of the bearing. Heat treatment. Induction heating is often used in the heat treatment of metal items. The most common applications are induction hardening of steel parts, induction soldering, brazing as a means of joining metal components, and induction annealing to selectively soften an area of a steel part. Induction heating can produce high power densities which allow short interaction times to reach the required temperature. This gives tight control of the heating pattern, with the pattern following the applied magnetic field quite closely, and allows reduced thermal distortion and damage. This ability can be used in hardening to produce parts with varying properties. The most common hardening process is to produce a localized surface hardening of an area that needs wear resistance, while retaining the toughness of the original structure as needed elsewhere. The depth of induction hardened patterns can be controlled through choice of induction frequency, power density, and interaction time. Limits to the flexibility of the process arise from the need to produce dedicated inductors for many applications. This is quite expensive and requires the marshalling of high current densities in small copper inductors, which can require specialized engineering and copper fitting. Plastic processing. Induction heating is used in plastic injection molding machines. Induction heating improves energy efficiency for injection and extrusion processes. Heat is directly generated in the barrel of the machine, reducing warm-up time and energy consumption. The induction coil can be placed outside thermal insulation, so it operates at low temperature and has a long life. The frequency used ranges from 30 kHz down to 5 kHz, decreasing for thicker barrels. The reduction in cost of inverter equipment has made induction heating increasingly popular. Induction heating can also be applied to molds, offering more even mold temperature and improved product quality. Details. The basic setup is an AC power supply that provides electricity with low voltage but very high current and high frequency. The workpiece to heat is placed inside an air coil driven by the power supply, usually in combination with a resonant tank capacitor to increase the reactive power. The alternating magnetic field induces eddy currents in the workpiece. Magnetic materials improve the induction heat process because of hysteresis. Materials with high permeability are easier to heat with induction heating. Hysteresis heating occurs below the Curie temperature where materials retain the magnetic properties. High permeability below the Curie temperature in the workpiece is useful. Temperature difference, mass, and specific heat influence the workpiece heating. The energy transfer of induction heating is affected by the distance between the coil and the workpiece. Energy losses occur through heat conduction from workpiece to fixture, natural convection, and thermal radiation. The induction coil is usually made of copper tubing and fluid-cooled. Diameter, shape, and number of turns influence the efficiency and field pattern. core-type furnace. The furnace consists of a circular hearth which contains the charge to be melted in the form of angular ring. The metal ring is large in diameter and is magnetically interlinked with an electrical winding energized by an AC source. It is essentially a transformer where charge to be heated forms a single-turn short-circuit secondary and is magnetically coupled to the primary by an iron core.